Hey guys, so this is our last lesson for algebra readiness for this year. This is the last assignment that you're going to have in this class all year long. So the last thing I wanted to make sure that you guys knew before you headed off into algebra next year is like terms. So like terms are when we have different terms in an expression or an equation, and the variable is the same in both terms, and the exponents of that variable are the same. So both of these things have to be the same. So when we're looking at like terms, we're focused on the variable part. So whether or not they both have an x or they both have a y, and if they're both x squared or y squared or just x, those would be the things that we want to look at and focus on for whether or not they're like terms. The number that's out in front, that's the coefficient. So just because they both have a coefficient of 2, like that doesn't mean that they're like terms. It just means that I have two x's and I have two y's. So another great way to think about this is, let's say you had, I'll do a drawing. Let's say that you have 3 oranges, okay, 3 oranges, and you have 2 apples. I'm going to put stems on the apples, okay? So 3 oranges, 2 apples. Now, I could see how many pieces of fruit I have, but apples and oranges aren't the same type of fruit. So I can't combine apples and oranges and then say how many oranges I have. Or combine them and say how many apples I have. They're not the same fruit, so I can't put them together and call them the same thing. So it's the same idea of what we're doing when we have 3 x's and 2 y's. If I wanted to add or subtract those, I can't do it because x's and y's aren't the same thing, so I can't put them together. So you can always go back and think about the fruit example if you start to get confused. So for our first example here, I have 6x plus 2y. Again, the number in front, that's the coefficient. That's just telling me how many x's I have. It's not telling me whether or not my terms are the same. So what's telling me whether or not my terms are the same is the variable part. And so if I look at these, they both have an x, and in both of them, x doesn't have an exponent. So same variable with the same exponent means they're like terms. So in order to combine them, that's like saying I have 6 x's and I'm going to add 2 more x's to it. So I'm just adding the coefficients. So 6. So if I combine my like terms, I end up with 8x. So the variable part is what you're checking to know if they're like terms. The number in front, which we call the coefficient, is telling you what to add or subtract to combine those like terms. So I made this second example a little bit more complicated. If we look at each of our terms, we have 4 terms now. I see that I have 2 terms that have x's and I have 2 terms that have y's. So these x's both have the same exponent, which is just 1, so there's no exponent written in. And these y's have the same exponent, they're just to the first power, so there's no exponent written in. So I can't combine my x's with my y's, but I can combine the 2 terms that have x's together, and I can combine the 2 terms that have y's together. So I already know from the first example that 6x plus 2x is 8x. And I can combine these two by adding their coefficients, and 3 plus 4 is 7, so 7y. I can't do anything more beyond that point. Always think back to the apples and the oranges. I can't combine apples with oranges and then say how many apples I have. I have 8 x's, I have 7 y's, but these two things are not like each other. They're different variables, so I can't combine them anymore. So this would be my final answer, just like that. All right, threw some exponents in here on this one just to make sure that we've seen it. So if I look at my first example, everything has an x. But if I look at each term more closely, I see that this one has an x squared. This one is to the first power, and this one has an x squared. So this term, this 3x, is not like the other two. It has a different exponent. So I can't combine it with the 2x squared or with the 5x squared. These two are both x's and they're both to the second power. They're both squared. So I can combine those two. So I'm going to look at their coefficients, the number in front, to see what I get. So 2x squared plus 5x squared, 2 plus 5 is 7. So when I combine those, I end up with 7x squared. Now, the 3x doesn't disappear and it doesn't combine, so I just have to write it there at the end. Our last example, I have x squared, I have an x, I have a y squared, and I have a y. So what's going on here? I've got two terms that have x's, but one has an exponent of 2 and one doesn't. So they have the same variable, but they don't have the same exponent, so I can't combine those. And if I look at my y's, one is squared, one has an exponent of 2, and one is just y. So they have the same variable, but they don't have the same exponent. So I wanted to put one in there just to show you that sometimes there's a lot going on and you want to think that you might have like terms, but you actually don't. There's nothing that I can do to simplify this. This would be like saying I have apples, oranges, grapes, and strawberries. So I can't combine my different types of fruit and then call them one type of fruit. So that is already done. You don't have to do anything on number 4. So it's as simplified as it can get. So when you're working through your problems today, make sure that you're paying especially close attention to the variables, whether they have the same variable, but then also make sure you're paying attention to whether or not those variables have the same exponent.